Now let's consider the spin quantum of the decay of the tau lepton. So we can look at the spin on the neutrino or muon neutrino part of tau lepton, and we see that it has a spin of -1/2, or is left-handed. And we can look at the boson minus and see that it has a spin of 0. That scalar intrinsic spin indicating that it represents an interaction with the Higgs field on the part of this muon neutrino, which creates the tau lepton. Now, the, of course, associated boson self-relating pair is 0 also. Now, if we look at the decay product, meaning the tau neutrino, we'll see that we have still the left-handed contribution of the muon or neutrino, and we have again a 0 contribution of this boson 0. Since now it indicates or represents the interaction of this muon neutrino with the Higgs field to create the tau neutrino. We also have over here the boson minus, which will be the W minus boson, and now is showing a intrinsic spin of 0, which will match the combined intrinsic spin of the antineutrino and the electron, there being a 1/2 intrinsic spin on the antineutrino and a -1/2 on the electron. Now, the weak charge. The weak charge on the muon neutrino is +1/2, which is predicted by the standard model for a left-handed neutrino. And on the boson minus, we have a -1 contribution. And so we have for the tau lepton a total of -1/2 for the left-handed tau lepton, which is predicted by the standard model. And for the self-relating pair, we have a 0 weak charge. Now, for the decay product, being the tau neutrino, we have first again +1/2 on the muon neutrino part of the tau neutrino, and on the scalar boson 0, we have a 0 contribution to the weak charge, so that, as predicted by the standard model, on the tau neutrino, left-handed, we have a 1/2 isospin weak charge. And on the boson minus, which will be emitted as a W boson, we have a weak charge of -1. And if we look at the decay products of the W boson, we will see that we have an antineutrino with a weak charge of -1/2 and a electron with a weak charge of -1/2, giving us a total isospin weak charge equal to the isospin weak charge of the boson minus. Now, to conclude, let's look at the color or chromodynamic charges. And we can see that the chromodynamic charges of the tau lepton and this associated pair of self-relating rishons is 0, which is predicted by the standard model because we have 3 anticolors on the neutrino part and opposite colors on each of the bosons. Also, we have a 0 color charge on the tau neutrino, having the 3 anticolors, and then opposite colors on the 2 bosons again. And then last but not least, we have the antineutrino, which has the 3 colors yellow, blue, and red, which are summing to 0, and on the electron, the 3 anticolors, purple, orange, and green, giving us a sum of 0 for the color charge. And so we have the quanta of the tau lepton and its decay products and see that they are consistent with the standard model.